Welcome back to another explainer. Today, we're diving straight into a high-energy geological journey, right deep into the Earth's magma factory. We're going to explore how intense heat, immense pressure, and, well, millions of years of chemical evolution beneath our feet give us the materials that literally build our modern world. Specifically, we are unlocking the secrets behind magmatic concentration deposits. I'm absolutely thrilled to take you through this because the processes here, they're nothing short of spectacular.
But before we get completely lost in the geology, let's tackle a really fascinating paradox. How exactly does liquid rock create solid wealth? We tend to think of the ground we walk on as, static and unchanging. But the reality is that deeply abstract, dynamic geochemical processes happening in these churning bodies of liquid silicate melt are exactly what produce the raw materials powering everything from your smartphone to the entire electric grid. So to really understand these magmatic concentration deposits, we've got a roadmap to follow the cooling magma step by step. We'll start with number 1, the Earth's magma factory, then move to 2, the orthomagmatic phase, 3, pegmatites, 4, hot fluids and porphyry ores, and finally, 5, mining magmatic deposits. Let's get right into it.
Section 1. The Earth's magma factory.
Okay, so everything begins with heat. The heat inherent in the Earth, which is generated largely by radioactive decay, by the way, acts as a massive planetary engine. This thermal energy creates powerful gradients that drive the dynamics of both the mantle and the crust. And under the right conditions, this heat actually initiates partial melting of rocks, creating these massive, buoyant bodies of molten silicate melt that we call magma. But here's the thing, this isn't just liquid rock. It's a complex, chemically rich soup that acts as the absolute starting point for concentrating all these useful elements.
Which brings us to Section 2, orthomagmatic, gravity and cooling. Now, just to be super clear on our terms here, orthomagmatic basically refers to ore deposits that form at extreme magmatic temperatures while the melt is still essentially liquid. So we haven't reached total solidification yet. This is an incredibly dynamic phase because the liquid state allows elements to move around, combine, and, most importantly for us, separate.
Imagine this whole process like a giant, molten snow globe settling over, say, thousands of years. As this massive body of magma slowly cools down, it approaches saturation for certain minerals. Heavy sulfide melts or solid oxide crystals start to unmix and form right out of the liquid. And because these droplets and crystals are packed with metals, they're much denser than the surrounding silicate liquid around them. So gravity takes over. It pulls them relentlessly downward, accumulating them in thick layers right on the floor of the magma chamber.
And this early cooling phase, it's essentially nature's way of concentrating incredible wealth, specifically nickel, copper, and platinum group metals. These aren't just, geological curiosities. They are the fundamental building blocks of modern electronics and the literal wiring in your house. A textbook example of this is actually found in Western Australia, where billions of years ago, dense, metal-rich droplets settled right at the base of incredibly hot, fast-flowing ancient lavas.
Now this illustrates a really dramatic shift in our magma's journey. We move from the early orthomagmatic phase we just talked about, which is dominated by those heavy, sinking metal droplets settling downward by gravity, into something completely different. As the magma keeps cooling and crystallizing, its behavior totally flips. We transition into the late-stage phases, which are dominated by highly volatile, upward-escaping fluids and gases that just refuse to be locked into the solidifying rock.
So let's look at Section 3, pegmatites, the final drops.
At this stage, most of the original magma has actually frozen into solid rock. But what's left over are these small, highly fractionated residual melt batches. You can kind of think of them as the very last drops of the silicate melt. Because so much of the standard rock-forming material has already crystallized, these final little pockets become intensely concentrated with things that just didn't fit into the earlier crystal structures. This enriches them heavily in volatiles like water, boron, and fluorine.
And these peculiar final drops are known as pegmatites, and they are absolutely fascinating. Because of that high volatile content, the viscosity of the melt is lowered, meaning elements can move around super easily. This allows for the growth of coarsely crystalline textures, sometimes forming literal giant crystals, stuff geologists actually refer to as books. But even more importantly, these pegmatites act as a final resting place for rare, highly incompatible elements like lithium, beryllium, tantalum, and tin. Crystallizing at intermediate crustal levels, these pegmatite deposits are essentially nature's battery factories. I mean, they hold the lithium we so desperately need today.
Moving right along to Section 4, hot fluids and porphyry ores.
As these highly volatile magmas ascend toward the surface, they experience a massive and rapid decrease in pressure. This causes the dissolved gases in water to become supersaturated. The magma literally starts to boil. This phenomenon, often called first boiling, creates a frothy, expanding fluid that aggressively scavenges remaining metals like copper and gold from the melt. And the pressure from these expanding fluids is just immense. It physically shatters and fractures the solid roof rocks above the magma chamber, forcing those metal-rich brines into literally every crack and crevice.
The result of this is absolutely staggering. These specific magmatic hydrothermal porphyry deposits account for 75% of the world's entire copper supply. Just think about that. By fracturing the rock and depositing metals in vast stockwork vein systems, the magma creates low-grade but incredibly massive ore bodies that form the entire backbone of global copper production.
Finally, Section 5, mining magmatic deposits. The sheer, breathtaking scale of human extraction here is just undeniable. Take the Chuquicamata open pit in Chile, for example, one of the world's largest porphyry copper mines. The footprint here is massive. It measures 2 by 3 kilometers across and plunges 900 meters deep into the earth. It's a literal man-made canyon. This single site holds nearly 3 billion tons of ore resources, and it was all made possible by those boiling magmatic fluids we just discussed, concentrating the copper there millions of years ago.
Now, if you zoom in on the actual rock, you can see the direct physical evidence of those violent processes. You'll notice the brecciation, the shattered, fragmented rock, laced with these really intricate networks of quartz veins. This pervasive alteration is exactly what happens when superheated, pressurized, metal-rich fluids blast right through solid rock.
I want to pull back for a second and consider this quote from our source material, because it really perfectly summarizes our journey today. Quote, "The heat inherent in the Earth and the energy received as radiation from the sun are causative agents. The formation of mineral deposits is an integral component. This beautifully reminds us that the mineral wealth we rely on, it isn't an accident. It is the direct physical byproduct of living on a highly dynamic, energetic planet."
So I'll leave you with this final thought. The next time you pick up your smartphone or, simply turn on a light in your home, take a second to ask yourself, what ancient magmatic journey made this possible? From heavy metal droplets settling in a subterranean magma chamber to superheated boiling fluids fracturing the Earth's crust, your daily life is deeply connected to the profound geological processes we just explored. Thanks for joining me on this explainer, and definitely keep questioning the incredible world beneath your feet.